Welcome to clickmyproject.com. We are going to see the product for an efficient on-chip switched capacitor-based power converter for a microscale energy transducer. Next, we are going to see the abstract for our product. Harvesting energy from ambient sources has become an attractive and promising option for powering the Internet of Things. The first DC to DC converter, which is boost charger, offers an optimal impedance to the harvester such that it can transfer maximum energy to the energy processing circuit, whereas the second DC to DC converter, which is a regulator, would provide a regulator supply voltage to the respective loads. A boost charger can be implemented as inductive, capacitive, or hybrid combination of these three. Compared to an inductive boost charger, the switched capacitor-based design offers better performances like system-on-chip solution, better compact chip area, minimum number of pads, external pins, and off-chip components. It also eliminates the bonding wire noise, effective series inductance of the off-chip components, and PCB trace. Therefore, a switched capacitor-based boost charger is preferred over an inductive converter. The switched capacitor-based boost charger is widely referred in literature as a charge pump circuit. A charge pump is an electronic circuit that can generate an output voltage which is several times higher than the supply voltage or lower than the ground potential by pumping or sharing the charges from one capacitor to the others. A detailed comparison of the major contribution in QP circuits along with the proposed. It is evident that the two-phase tree topology QP is better in some aspects. Next, we are going to see the flow diagram for our product. Here, the ring isolated buffer stage and power transistor is for generating the clock signal. The clock signal is added with the voltage source and is given as input to the single stage tree topology QP. A current star ring oscillator with progressive sizing inverters is used for generating a clock signal. In order to avoid the body effect issue on MOSFETs, a triple well process is used. The energy buffer represents a supercapacitor or a rechargeable battery where the harvested energy is being stored to supply the load and the interface circuits. However, in terms of hardware cost, complexity, area, and conversion efficiency, the proposed one performs better than the tree topology of the existing system. The operation mechanism of the proposed QP is during the positive half cycle, the capacitor C2 will be charged by the harvester, and the capacitor C1 will transfer its charges to C3. During the negative half cycle, the capacitor C1 will be charged by the harvester and the capacitor C2 and C3 along with Vn will transfer the charge to the next stage capacitor or to the storage capacitor STO. Unlike linear QP, the tree topology QP utilizes both the half cycles, which is positive and negative, to extract charges from the harvester, which in turn improves charge sharing time and charge transfer capabilities. Diode connected MOS devices are avoided in order to achieve the better pumping gain. Moreover, by carefully placing MOS switches with appropriate gate control signals, reverse charge sharing is minimized. Next, we are going to see the output for our product. We designed the circuit in Tanner version 13.0. I have created the design in this cell. To create a new design, you have to click on the file and then give the new design. Then create a new cell. You have to click on the cell, new view. Add the library files to create the components. Then you have to click on the setup and give the space simulation. And in the library file, you have to browse for the library file. In this, the code containing folder contains the libraries, and you have to click on the libraries and then give the models and then give the library file. and give and specify the folder names and give the space and type tt, and then give the stop time 200 nanoseconds, maximum time step 1 nanoseconds, print start time 0 nanoseconds, print time step 1 nanoseconds. Take the transient Fourier analysis and then click on OK. Then run the simulation. The output will be generated. Thank you.